Hi Year 12. This is the final video for the solutions to the 2022 Maths Extension 1 HSC exam paper. In this video we're going to look at questions 13 and 14. Question 13a, three different points A, B and C are chosen on a circle centered at O. Now let A be the vector OA, B be the vector OB and C be the vector OC, and also H is the vector OH. And we're also given this, H is equal to A plus B plus C. Show that vectors BH and CA are perpendicular. So of course what we want to do is prove that the dot product of those two vectors is equal to 0. So let's make some substitutions. BH, that's here. Okay, that's going to be negative B plus H dot, and then we've got CA, which is this one here, and that is going to be negative C plus A. Now we're going to use this part. So instead of H, I'm going to put in A plus B plus C dot. Just turn that around, A minus C, and that's going to be equal to A plus C dot A minus C. So we've got the difference of two squares. So this is A dot A minus C dot C. Now this of course is exactly the same as the magnitude of A all squared minus the magnitude of C all squared. And this is going to be equal to 0 providing magnitude of A is equal to the magnitude of C. And it is, isn't it? Because they're radiuses or radii of the same circle. So we've proven it. 13b. A solid of revolution is to be found by rotating the region bounded by the x-axis and the curve y equals k plus 1 in brackets sine kx. K is greater than 0 between x equals 0, x equals pi on 2k about the x-axis. Find the value of k for which the volume is pi squared. So if we're rotating about the x-axis, we want this formula. We want dx, so we want y squared. All right, so volume is equal to pi. Now we know A and B, there they are. So between 0 and pi on 2k of y squared, so that's this here, k plus 1 all squared sine squared kx dx. All right, I'm going to bring this k plus 1 squared out the front because it's a constant. And we've got between 0, pi on 2k. Now we've got this part left, and I'm going to use this identity to be able to integrate it. So I've got a half, throw that out the front as well, 1 minus cos 2kx dx is equal to k plus 1 all squared pi over 2. Let's integrate. X, take away, is a reverse chain rule, so we've got the integral of cos is sine 2kx, divide by the derivative of this inside function, which is 2k, in between 0 and pi on 2k. And we want that to equal pi squared. So I can immediately see that one of those pi's is going to cancel out. So we have, let's take that 2 over, 2 pi is equal to k plus 1 all squared, and now let's substitute in pi over 2k minus sine 2k pi over 2k all over 2k. Take away, now let's substitute the 0 in. We're going to get 0 and 0, so that's good. Okay, so 2 pi equals k plus 1 all squared, pi over 2k. What do we got here? That cancels, sine pi is 0. 0 take away 0, nothing actually. So we need to solve for k. I guess I need to expand that all out. Actually, let's take this up and over. And in fact, we can cancel that pi, can't we? So we've got 4k is equal to, and now expand that out, k squared plus 2k plus 1 k squared minus 2k plus 1 is equal to 0. It's a perfect square, isn't it? Therefore, k is equal to 1. 13c. The function f is defined by f of x is equal to sine x for all real numbers x. Let g be the function defined on this domain by g of x is equal to arc sine x. Is g the inverse of f? Justify your answer. Well, the short answer is no, it's not. And the reason, if we look at y equals sine x, it's a graph that goes on forever and ever because its domain is all real x. Now, when we go to form the inverse function and we switch our x's and y's and we have a look at the graph of it, we don't get a function, we get a relation. So do you remember what we do? We restrict the domain of f, and that gives us inverse sine there. Now that's probably not enough for 2 marks, so one thing that you can do is there's another definition for inverse functions. G will be an inverse if g of f of x is equal to x for all real numbers x. And it's not. So let's find an example of an x where that's not the case. Let's try x is equal to 3 pi on 2. Now f of 3 pi on 2 is equal to sine 3 pi on 2, which is -1. And g of -1, so looking at our graph here, that's going to be that point there, is equal to -pi on 2. So g of f of 3 pi on 2 is not equal to 3 pi on 2, it's equal to -pi on 2. So therefore g is not the inverse of f. 13d. The monic polynomial p has degree 3 and roots alpha, beta, gamma. These two equations are given. Find this. Alright, if these are the roots of the polynomial p, then we can write p of x like this. And when you expand that all out, and you have seen this before, you get this. X cubed take away the sum of the roots, plus the sum of the pairs of the roots. Take away the product of the roots. All right, let's differentiate. With respect to x, we get 3x squared. Take away 2 lots of alpha plus beta plus gamma x plus alpha beta plus beta gamma plus alpha gamma. All right, now let's use this equation here. So p dashed of alpha plus p dashed of beta plus p dashed of gamma is equal to, are you ready? 3 alpha squared minus 2 alpha plus beta plus gamma alpha plus, put this in brackets, alpha beta plus beta gamma plus alpha gamma plus 3 lots of beta squared, take away 2 lots of alpha plus beta plus gamma times beta. Can you see I'm going to get 3 of those? So I'm just going to do a sneaky 3 there so I don't have to keep writing that out. Plus, substituting gamma, 3 gamma squared minus 2 alpha plus beta plus gamma times gamma. Now we're told that this first bit here is equal to 87. That's going to be equal to, let's factorize this all together. So 3 lots of alpha squared plus beta squared plus gamma squared. I'm going to put that guy to the end, and then I've got this and this and this together. So -2 lots of, and let's expand that part out there. So that's alpha squared plus beta alpha plus gamma alpha. Now this guy plus alpha beta plus beta squared plus gamma beta plus, now I'm here, alpha gamma plus beta gamma plus gamma squared, and don't forget this guy here, plus 3 lots of alpha beta plus beta gamma plus alpha gamma equals, alright, so 3 lots of alpha squared plus beta squared plus gamma squared. Take away, I've got 2 lots of this, do you see that? 2 lots of alpha squared plus beta squared plus gamma squared. And then I'm going to have 2, inside these brackets, I'll get 2 lots of each of these pairs. Where's the other one of those? Alpha, beta, oh there. So I'm going to have, take away, 2 lots of alpha, beta plus alpha, gamma plus beta, gamma. Take away, oh no, add that. 3 lots of alpha, beta plus beta, gamma plus alpha, gamma. Equals 3 lots of this, take away 2 lots of that, is 1 lot of that. And then I've got minus 4 lots of the sums of the pairs plus 3 lots of the sums of the pairs, so that's take away 1 lot of the sums of the pairs. And we know that's 87, so 87 is equal to, we know this, it is 85, take away alpha beta plus beta gamma plus alpha gamma. Alpha beta plus beta gamma plus alpha gamma is equal to 85, take away 87, which is equal to -2. 13e. Chocolate factory sells 150 gram chocolate bars. There has been a complaint that the bars actually weigh less than 150 grams, so a team of inspectors is sent to the factory to check. They randomly selected 16 bars, weighed them, and noted that 8 bars weighed less than 150 grams. The factory manager claims 80% of the chocolate bars produced by the factory weigh 150 grams or more. The inspectors used the normal approximation to the binomial distribution to calculate the probability P of having at least 8 bars weighing less than 150 grams in a random sample of 16. Assuming the factory manager's claim is correct, calculate the value of P. All right, so what do we know? We know that this is going to be a normal approximation to the binomial distribution. So let's set up a variable. We're going to call x the number of bars that weigh less than 150 grams. And so x is going to be distributed as a binomial distribution. Number of trials is 16, and the probability of success, this is success here, is going to be 20%. Now we know that we can do a normal approximation to the binomial distribution, so let's use some formulas. We know mu will be NP, which is equal to 16 times 0.2, which is 3.2, and standard deviation will be the square root of NP brackets 1 minus P, which is the square root of 16 times 0.2 times 0.8, which is square root 1.6. So we have that x normal is normally distributed with mean 3.2 and standard deviation is 1.6, so variance is 1.6 squared. So we want to work out the probability P of having at least 8 bars weighing less than 150 grams. So in other words, probability that x norm is going to be greater than or equal to 8, because remember I made success being that they weigh less than 150 grams. So we're going to use a z-score. So it's going to be the probability that z is going to be greater than or equal to 8 take away mu on sigma. And that's the same as the probability that z is greater than or equal to, let me grab my calculator, 8 take away 3.2 on 1.6, which is 3. Now it says up the top here that we could use the information on page 18, but this is actually one of our empirical values. So do you remember this? 3 standard deviations either side of the mean. Do you remember the percentage? That's 99.7%. So in here and here is 0.3, and in this side, which is where we want it, it's 0.15. So this probability is 0.15%. Part 2, the factory manager disagrees with the method used by the inspectors. Explain why the method used might not be valid. Now we've got 1 mark here, so we don't have to say a lot. It's obviously to do with the sample size. So if you just say that, you're going to get the mark. But we already worked out what NP was. It was 3.2. And do you remember learning that we really need NP to be greater than or equal to 5 for us to be able to use a normal distribution? So that's a better answer, but if you just say it's to do with the sample size being too small, you're going to get it correct. 14a, find the particular solution to the differential equation x minus 2 dy dx equals xy that passes through the point 0, 1. All right, we're going to use separation of variables. I'm going to get everything that's x on the right-hand side and everything that's y on the left-hand side. I'm going to end up with 1 on y dy is equal to x over x minus 2 dx. Don't forget your integral signs. All right, so on the left-hand side, I'm going to have ln y is equal to, how do we integrate this? There's a bit of a trick to it. I'm going to match the denominator. So instead of x on the top, I'm going to write x minus 2. But of course, I can't just introduce a negative 2. I need to adjust it. So minus 2 plus 2 is 0. I haven't changed anything. And why do we do that? Because now I have a top-heavy fraction that I can split. So this is equal to the integral of x minus 2 on x minus 2 is 1 plus 2 over x minus 2 dx. All right, so ln y is going to be equal to x plus 2 ln x minus 2 plus c. I'm going to tidy this up before I substitute this point in. So let's just do a little bit of fixing. This is equal to x plus, I'm going to do ln x minus 2 all squared plus c. And now let's get those logs together. So I've got ln y, take away ln x minus 2 all squared is equal to x plus c. And this becomes ln of y over x minus 2 squared is equal to x plus c. All right, raise both sides as powers of e. So y over x minus 2 all squared will equal e to the x plus c. And I'm going to split this, make it e to the x times e to the c, and then rewrite that as a e to the x. And then multiplying both sides by x minus 2 squared, get y is equal to a e to the x, x minus 2 all squared. Now we're going to substitute this point in. So when x is 0, y is 1. Negative 2 all squared, which is equal to, 1 is equal to a times 4, so a is equal to a quarter. So our particular solution is y is equal to e to the x on 4x minus 2 all squared. Question 14b. The vectors u and v are not parallel. The vector p is the projection of u onto the vector v. So here's vector v, here's u, and projection onto vector v is vector p. Vector p is parallel to v, so it can be written as a lambda naught v for some real number lambda naught. Prove that this is smallest when this is the case. And by showing that for all real numbers this is true. Now here this is u minus lambda naught v. So basically we want to prove that the shortest distance between a point and a line is the perpendicular distance. Okay, so the way to start. We can't do anything with this. It's too tricky. So I'm going to start with this side. Now, one of the best techniques is this. Is to square this, because this is equal to u minus lambda naught v dot u minus lambda naught v. We can expand it. Now u dot u is this. Take away 2 lambda naught u dot v plus lambda naught squared v squared, magnitude of v squared. All right, I'm going to tidy that up in a second. Now, the other thing I know is this. The projection of u onto v can be written as u dot v divided by v, magnitude of v, times by the unit vector v. Now I'm going to write this a little bit different. Let's put a times in there. I'm going to get rid of this unit vector here and divide by the length squared, because then this here, because remember this is p, this is going to be lambda naught. And now I'm going to substitute that into here. And so we get magnitude of u squared plus lambda naught squared, magnitude of v squared. Now substituting in for u dot v, we get lambda naught magnitude of v squared equals magnitude of u squared, take away lambda naught squared, magnitude of v squared. Right, now let's do the same for the other side, this one here. So we've got u take away lambda v squared is equal to magnitude of u squared plus lambda squared magnitude of v squared take away 2 lambda u dot v. Substituting in again, we get this minus 2 lambda naught magnitude of v squared, and let's just factorize, plus this, actually that won't be a squared, get rid of that, and brackets lambda take 2 lambda naught. So what I'm going to do is look at this one, take away this one, because that should be positive. This should be longer than that. Okay, here we go. So magnitude of u, take away lambda v all squared, take away magnitude of u, take away lambda naught v all squared is equal to magnitude of u squared plus lambda v squared, magnitude of v squared, brackets lambda take 2 lambda naught, take away brackets magnitude of u squared, take away lambda naught squared, magnitude of v squared equals, right, that cancels with that, and we're left with lambda magnitude of v squared, lambda take 2 lambda naught, take away, add lambda naught squared, magnitude of v squared. Right, factorize these magnitude of v squareds out. I'm going to expand this out. Lambda squared take 2 lambda naught plus lambda naught squared. That's perfect square, isn't it? So this is lambda take lambda naught all squared. So that whole thing, that's positive and that's positive. So this is greater than or equal to 0. So we have proven that magnitude of u take away lambda v all squared is greater than or equal to the magnitude of u take away lambda 0 v all squared. Therefore, magnitude of u take away lambda v is greater than or equal to magnitude of u take away lambda naught v. Now, are you happy with that line? The reason we can say that is because these are lengths and they are both positive. So, therefore, it is proven. Question 14c. A video game designer wants to include an obstacle in the game they are developing. The player will reach one side of the pit and must shoot a projectile to hit a target on the other side of the pit in order to be able to cross. However, the instant the player shoots, the target begins to move away from the player at a constant speed that is half the initial speed of the projectile shot by the player, as shown in the diagram below. The initial distance between the player and the target is d. The initial speed of the projectile is 2u and it is launched at an angle theta to the horizontal. The acceleration due to gravity is g. The launch angle is the only parameter that the player can change. Taking position of the player when the projectile is launched as the origin, the positions of the projectile and the target at time t after the projectile is launched are as follows. Show that for the player to have a chance of hitting the target, d must be less than 37% of the maximum possible range. Alright, first thing we're going to do is find this point of intersection. Actually, I'm only going to try and find the x coordinate where these two equations meet. So that means equating this and this. So 2ut cos theta is equal to d plus ut, making d the subject. It's equal to 2ut cos theta minus ut, and factorising ut brackets 2 cos theta minus 1. So the next thing we're going to do is work out this maximum possible range, because if you're in a question like this and you don't know what you're doing, try and get marks, that's going to give us a mark. Now, the range is going to occur when y is equal to 0. So we want to solve 2ut sine theta minus g on 2t squared is equal to 0. Factorise. Minus gt on 2. Obviously t won't equal 0, so we need to solve that bracket equal to 0. So 2u sine theta is equal to gt on 2. So t is equal to 4u sine theta on g. Now that's not the range, that's the time it takes to hit the ground here. We need to substitute back into our x coordinate to get the range. So the range is going to be 2u, 4u sine theta on g times cos theta is equal to 8u squared on g sine theta cos theta. Or we could write it as 4u squared on g sine 2 theta. Now that's the range, not the maximum range. And our maximum range occurs when? When theta is equal to pi on 4. So the maximum range is equal to 4u squared on g, because sine pi on 2 is equal to 1. Okay, let's finish this off. We have an equation for d, and this is the time of flight. Now if you think about it, say this is the time of flight and this is d at that particular time, the most we want d to be is what I get when I substitute this time of flight in. Does that make sense? So this is the maximum that I want d to be. If d is any bigger, this thing's going to just fall down. Yeah, I think that makes sense. All right, so substituting in. So 4u sine theta on g brackets, and then brackets 2 cos theta, take away 1. And tidying that up, I get 4u squared on g sine theta, 2 brackets cos theta. I don't know why I did bracket there. Let's get rid of it. 2 cos theta, take away 1. All right, we can see some similarities here. There's the maximum range. Can you see that? So it would be really good if this, the maximum this could be would be 37%, because that would be the answer. So what we're going to do is maximize y is equal to sine theta, 2 cos theta, take away 1. So expanding, we get 2 sine theta cos theta, take away sine theta, which is equal to sine 2 theta, take away sine theta. And differentiating dy dx is equal to 2 cos 2 theta take cos theta. And we want this to be equal to 0 so we can find the maximum that it's going to be. Now I'm going to make a substitution in terms of cos. So 2 brackets 2 cos squared theta minus 1, take away cos theta is equal to 0. 4 cos squared theta take 2 take cos theta is equal to 0. We're going to have an equation that is reducible to a quadratic. I'm not going to make a substitution, I'm just going to do the quadratic formula. Cos theta is equal to negative b, so that's 1 plus or minus the square root of b squared minus 4 times a times c, all over 2a, which is 8. Now, do I need this plus minus here? No, this is an acute angle. Cos has to be positive, so let's get rid of that. So cos theta is going to be equal to, got my calculator, 1 plus the square root square root of 1 plus 4 times 2 all over 8, which is 0.843. And then theta will equal, so inverse cos 32.534. So this angle here will maximize that part there. So let's work out what that's equal to. So sine of 32.534 times 2 times cos 32.534 take 1 is equal to, so sine, no, that's 10. Sine of answer times brackets 2 times cos of answer brackets, take away 1, close our brackets. Ta-da, 0.369, so 36.9%, which is approximately equal to 37%. Now you probably should prove that this is a maximum, but I've run out of room, so I will leave that to you. Question 14D. An airline company that has empty seats on a flight is not maximising its profit. An airline company has found that there's a probability of 5% that a passenger books for a flight but misses it. So probability misses the flight is equal to 5%. The management of the airline company decides to allow for overbooking, which means selling more tickets than the number of seats available on each flight. To protect their reputation, management makes the decision that no more than 1% of their flights should have more passengers showing up for the flight than available seats. Given management's decision and using a suitable approximation, find the maximum number of tickets to be sold for a flight which has 350 seats. So we want the probability that we have more than 350 people turning up to be less than or equal to 1%. Now this here should give you a bit of a clue. A suitable approximation means we're going to approximate using a normal distribution, and that's further backed up by this because we're going to use z-scores. Alright, so how do we turn this into something with z-scores? Now this currently is a binomial distribution. In fact, x is distributed as binomial. We don't know how many tickets we're going to sell, and the probability, let's call success, that a person makes the flight, catches the flight, and that's going to be equal to 95%. Now we want to approximate this as a normal distribution, and so we're going to want mu and sigma. Now we know that it's actually on our reference sheet. So mu is going to be equal to NP, we don't know what N is, times by 95%. And sigma will be the square root of variance, so square root of N times P times 1 minus P, which is 5%. And just grabbing my calculator, I'm going to simplify that a little bit. What do we got? 0.95 times 0.05 is 0.0475. 0.0475 n. So x, the normal approximation, is going to have mean 0.95 n and variance 0.0475 n. So let's work out the z-score. So z is equal to x, take away mu on sigma. X is 350. Mu is 0.95 n, and sigma is the square root of 0.0475 n. Now, we want the probability that z is going to be greater than, don't know, we want that to be less than or equal to 1%. Okay, so let's just have a look at a quick diagram and see what's going on here. So we've got 350 here if we're talking about x, and this is 1%, and if we look down here and make 1% there, in between there we've got 98%, and that's not one of our empirical rule values, so we're going to have to go to z-scores. So in this particular set of tables, this point here is x is equal to 350, and here we've got 1%. So all of this is 99%. So we're kind of working backwards. We want to find 0.99. And it's actually here, isn't it? So our Z score there is going to be 2.33. All right, we're ready. So 2.33 is equal to 350, take away 0.95n, all over the square root of 0.0475n. Right, multiplying both sides by the square root of 0.0475n, putting that equal to 350, take away 0.95n. I'm just going to get this number out of there and multiply it by 2.33. So I'm going 2.33 times square root of 0.0475, which is 0.5078 times the square root of n. Now adding 0.95n and then take away 350 equals 0. We nearly have an equation here that can be reduced to a quadratic. And all I have to do is let n equal m squared. So I've got 0.95 m squared plus 0.5078 m, take away 350 is equal to 0. So I'm just going to do the quadratic formula here. M is equal to negative 0.5078. I only need the positive because remember n represents the number of tickets we're going to sell, so it's going to be positive. Square root of b squared minus 4 times a times c all over 2a is equal to, all right, let's see if I can get this right, negative 0.5078 plus the square root of 0.5078 squared minus 4 times 0.95 times negative 350 all over 2 times 0.95 is equal to 18.9. Now that's not the answer because remember we made this substitution. So m squared is equal to n. So n is equal to 18.9 squared, which is, square it, press equals, 358. So the company can sell 358, this is 358.3, 358 tickets.